we'll start again then, ladies and gentlemen. DMF, the story so far. The first thing I need to do is to clarify what I'm going to be talking about in terms of DMF, because for 40 years in the lab I called dimethyl formamide DMF. Very powerful organic solvent beloved to PU chemists. Well, about 4 or 5 years ago we had to learn about a new DMF, which is dimethyl fumarate. And it's dimethyl fumarate which I'm going to be talking about today. So whenever I say DMF, that's the DMF that I mean. Now, in deference to the Secretary of State for Education, who keeps telling us how wonderful science teachers become over the last 10 to 12 years, I thought I'd show you the structure of DMF as a load of balls. Now, DMF has several uses. It's used as a preservative in animal food stocks. It's also a fungicide biocide. It's also used in various medicines, both applied to the skin and offered internally to cure or treat conditions such as psoriasis. It's also a known sensitizer. If you're exposed to DMF for long periods or for high levels, the skin will become sensitized, and it's important to remember that as we go through this talk. It's not in the same league as some of the more severe materials, but it is a known sensitizer. So just let's look at some of the problems that this work sets out to address. About 4 years ago, DMF began to be incorporated, particularly in leather upholstered furniture, to act as a fungicide biocide, to protect the product against mould during transit. And it was normally incorporated in the product in the form of a small sachet, crystals of solid DMF in a small sachet. They look very similar to the sachet of silica gel that you often find in leather products. So this began to happen in China and other parts of the Far East about 4 years ago. Shortly after they began to use the DMF in the upholstered furniture and the other leather products, there were reports of severe skin irritation. And you may have seen the TV programmes and read the press reports. People were claimed to be being burnt by sitting on the settee or using the other leather products. And DMF and the allergies were immediately linked. I have to say at the beginning, with not the greatest of scientific evidence. People made this link, but there's DMF in there, we can't find anything else to explain the allergies, let's blame the DMF for the allergies. So the DMF and the allergy were linked, and as a result of that, in the early part of this year, the use of DMF in the EU was banned. So you can't import products which are contaminated with DMF or use DMF in certain products in the EU as a result of these two incidents. When I say banned, I need to clarify what I mean by banned. The EU used what's known as a decision under their powers under the General Product Safety Directive to bring in a temporary ban on DMF operated from the 1st of May this year, and in March next year that ban will be up for renewal. Now I'll give you two guesses on whether it's going to be renewed or not. This is the EU we're talking about. Okay, so it's a temporary ban, but I suspect this temporary ban will become a permanent ban in the fullness of time. However, having banned it and said you can't have more than 0.1 part per million in your product, there is no official test method to analyse the leather products for the DMF. This is not unusual with other bans that the EU, the Commission have brought in, to find that there is a ban but no way of actually telling whether the product contains it. So we do have a problem at the moment with no official ES method for DMF analysis in leather products. There is also not a great deal of understanding of how the DMF can get from this sachet in solid form into the leather, or indeed onto the person's skin that's sitting on the leather or wearing the boots or handling the handbag. So there's not a lot of understanding about that mechanism, and again this work sets out to shed some more light on that. Quite interestingly, there are quite a few cases, I've said several there, but it could run into hundreds, of cases of skin irritation of people using leather product where we know that no DMF is present, no DMF has ever been used. used. So, although there are cases where DMF has been used in skin irritation and piercing, there are quite a few, probably more, that are not. So that has led us to the conclusion that there must be something else in the leather to blame for these other allergies. And we are talking, if you read the press reports and believe the press reports, of it could be tens of thousands of people suffering these allergies. Ah, that's better, on the screen now. We've got a start problem that's not showing up on the screen here, so if I keep sort of dobbing around, you'll know why. One of the other problems was that we got some shock headlines, and the leather industry as a whole was being blamed for these problems with the allergies. And that's typical, that's one of the most recent ones that appeared in a trade magazine. Chinese sofas burn 5,000. Well, there's not a great deal of evidence to support any of that. Some of these sofas actually came from Italy. There's one very well documented case of a settee made and sold in Italy that caused a lady to have burns. And where the 5,000 comes from, well, it's just a figment, I think, of the journalist's imagination. But there were quite a number of shock headlines, and I've got a folder which is about an inch thick now of all the press cuttings that allude to this particular problem. It's just a general shot of all the boots, shoes, handbags, upholstery, clothing, gloves that we're talking about. That's the way the settees, the sofas, would typically be shipped from the east to the west. They would literally be bundled up in polythene, taped up, put on pallets, shipped in containers from the Far East back to the west. Right, now let's have a look at some of the work that we've been doing. We know that DMF sublimes, it turns from a solid to a gas at somewhere between 30 and 50 degrees C. If you look in the literature, the sublimation temperature is not at all clear. But we do know that it sublimes, and it has to do that to work. If you remember, it's in a solid form, in a sachet, in the settee or the pair of boots. To act as a biocide fungicide, it has to turn to a vapour. So it's a bit like mothballs, it can't really just sit there as a solid. And what we're interested in finding out is what would happen to these sachets during the period of transit from the Far East. Would they actually volatilise? Would they actually turn from solid to gaseous form? Now, several years ago, and this work goes back about 5 or 6 years, we were interested in monitoring conditions during shipment for other reasons. So we put tiny little sensors in containers on board ship, both on the deck and in the hold. And these little sensors record, they're really data loggers attached to temperature and humidity probes. They record what happens over a period of time, and we can download them when the ship gets into port. So we put them into containers, so on deck and in the hold. And I apologise for the busyness of this slide, but this is the recording from one of those sensors. This actually went from Thailand to the northwest coast of America, Seattle or somewhere like that, Portland, Oregon, somewhere like that. And if you focus on the red line, that's temperature inside the container. And you'll see that that peaks at somewhere around 55 degrees C, dips down during the transit. This took about 6 weeks to get from the Far East to northwest America. Dips down during periods to around 2015, that sort of area. But for quite a lot of the time, it's back in 35 plus. And you can see there are quite a number of days when it's up into the 55 region. So our belief was that what was happening was the DMF was subliming, vaporising in the container. It would then go into the leather, but would very probably come out again. Okay, it goes in, solidifies, and then comes out again. So we wanted to test that theory out by doing some experiments in the lab. Could we make that, could we reproduce those shipment conditions in the lab? Now we couldn't use, or we didn't want to use 3-piece suites. They take up rather a bit of lab space. So instead we decided we'd use leather shoes with various components similar to leather furniture, and we would box those up. We sealed them in boxes with sachets of DMF, and we stored them at various temperatures for periods up to 4 weeks. And every week we took the shoes out and we analysed them to see what effect the storage conditions were having. We used a range of temperatures from room temperature up to 50 C, We only used 4 weeks, but I think that's going to test a fair amount of what might happen in transit that takes 6 to 8 weeks. That's just a little reminder. That's the one on the right is a silica gel sachet. The 2 on the left, one is silica gel and one's DMF. They are quite similar, the DMF and the silica gel. That's the way they're fixed to the furniture. At 50 degrees C, which is not untypical of what might happen inside this container, we found that the DMF builds up in the leather upper of our black boot. After 7 days, from 0 it had reached 300 ppm. It carried on gaining a bit of DMF for a few days after that, but after 28 days, this was a boot that was left in there for 28 days continuous, it began to drop. And we found a drop, in this particular case, to around 200 ppm. When you take it out, which is going to happen when the container ship gets to the port, you take the product out of the container, you leave it in a warehouse, you might even take it to someone's shop or home. Then we found after 48 hours, the DMF content dropped dramatically. But that's the result at 37 degrees C. I could give you other results at 23, 25 degrees C. You always get this massive drop once you take it out of its sealed container and allow it to air off. Just so you know, that wasn't a fluke. This is the same experiment, but we used several different types of shoe. This is a suede leather upper. After 7 days, again at 50, 600 parts per million of DMF from 0. But again, we get the same pattern. The longer we leave it in there for, the lower the level is. It begins to drop. And once you take it out and air it off for just a couple of days, then it drops quite significantly. And we believe this is now beginning to explain the mechanism of how the DMF gets from the sachet into the leather. It also goes into other things, because in our tests, parts of the footwear, the textile parts, the foam parts of the lining, as well as the packaging in the box, also picked up significant amount of DMF. Same pattern. It picks it up, it increases, then after a period of days it drops again. As soon as you take it out, take the box out of its wrapping, the DMF disappears. So we used a range of temperatures at 23 degrees C, in other words, normal, ambient, UK, typical. This hotel's a bit hotter than 23, but that sort of temperature, you pick up very, very little. You transport the DMF sachet cold, then you pick up very little in the product that it's there to protect. One would also reach the conclusion then that it's not acting as a biocide, it's just sitting there as a solid doing absolutely nothing. It does have to exceed, we think, around 40 degrees C to do its job, to stop the bug, to stop the mold growth. But at that temperature, then obviously it's in this weird and wonderful in out sort of mechanism. So that's the DMF sachet at the top, handily labelled anti-mold, do not eat. Very similar to silica gel. You'd be hard pressed to actually tell the difference. So we believe that it becomes hot enough to vaporise and during transit, condense back into the leather. If you transport it cold, then it could very well still be solid when it arrives in the UK or into its final destination. That bottom bit is important because people are putting the DMF sachets into product made, say, in Eastern Europe and transporting it overland. One has to ask the question, why? And would it work as an anti-mold? Probably not. So, although we think we know the mechanism how it goes in and out, after 6 to 8 weeks at sea and possible storage at ambient temperature, how much DMF would be present in the leather when it actually gets into someone's home or onto their feet or in their hands? I think our findings would suggest that in the vast majority of cases the product would contain very little DMF. There's not a lot of compelling evidence to suggest that the sachet in the suite would actually end up giving high levels of DMF in the product. Added to that, the medical data that is available suggests that you need a fair dollop of this in order to get an allergic reaction, even when the person has been sensitised. So, you know, we're looking at probably levels in the product of, let's say, 50, 60, 70 ppm. We need a lot more than that to get an allergic reaction. We've looked at a fair number of leathers, both from sweets where we know the history and others that have just been taken at random, and we've failed to detect significant levels of DMF in any of those. I'll just repeat that. Where we know the history, we know that some of these sweets have given rise to an allergic reaction. No DMF has been detected. We've also spoken to several of the manufacturers, and these same things have been reported in the press. We've talked to various tanners who have produced leather for both sweets and handbags and footwear. They claim never to have used DMF. Our investigations would support those claims. But you are then left with the problem of what's causing these reactions. During the course of this, we've had to analyse our leathers. So we have actually developed a method of analysis that's currently being considered as a PREN, a provisional European method. It's fairly straightforward. It's a solvent extract followed by GCMS analysis. Satra's working with several other European institutes, and I think we're confident that this method is now reasonably sound. To begin with, recovery levels were not very good. Detection limits are currently being refined. We are quite confident now that this method will give good results. I'm not sure that we've got detection limits yet that are going to go down to 0.1 ppm, but we're getting towards that way. So, if DMF is not the whole problem, what the devil is happening to cause these allergic reactions? Satra reached this conclusion quite some time ago, and I think the trade press and some of the other commentators are now reaching the same conclusion, that there must be something else there that's giving rise to these reactions. And in fact, various lawyers working for people who have suffered allergies are also coming to the same conclusion. Well, we took our same bundle of leathers, some with known history, some taken at random, and we looked at these for what I'll call the well-known culprits. We very rarely found chrome 6 hexavalent chrome at significant levels. It was normally well under 10 ppm, and in most cases under 3, in other words, non-detectable. Similarly with pH, it was normally back in around 4. It was in the normal range that we'd expect. So we couldn't really say, well, the leather's acid, it's causing these burns or allergies. However, during our trawl through these leathers for what I will call the known culprits, we did find one that would appear to explain some of the problems that we were looking at, and that was formaldehyde. In quite a number of cases, we found formaldehyde. I've said up to around 300 ppm. The data I'm currently holding suggests it's over 300 ppm in some cases, somewhere between 300 and 400 ppm. So in a significant number of cases, we did detect levels of formaldehyde, which were quite high. I mean, some of these results were frighteningly high. With leathers with known history, I think that 20 plus is actually 22. Only 2 showed very low levels of formaldehyde. And although it's a very small sample, 25%, a quarter of them, had levels well over 100 ppm. Now, if you look at the literature for leather, most people reckon values in the region of 100 to 150 ppm should be safe. If you look at the data for other substances, particularly textiles, and textiles that might be used, say, in children's clothing, then you find a lot lower levels being cited as safe, down to 20, 30 ppm. And in fact, I was looking at some literature only recently where I think automotive upholstery manufacturers are asking for less than 10 ppm of formaldehyde. They're looking for very low levels. So although those are the levels that we would traditionally think of as being safe, they might very well not be. And if we were to put a value of 50 ppm as safe, if we were to take that level as safe, then of our 22 leathers, 18 would be unsafe, 2 would be borderline, 2 would be safe. Now, it is a relatively small sample, I do accept that, but I think this does explain in some cases some of the problems that we're seeing that are not associated with DMF. So, what conclusions can we draw? Well, the first conclusion is don't jump to conclusions, because the press, and certainly did, and don't jump to conclusions without evidence. It was surprising how various test houses and research sessions actually got drawn into this and started to blame DMF with the scantiest of evidence. And certainly don't use scaremongering headlines, and don't try to blame the whole leather industry for one particular set of problems. DMF was certainly responsible for some of the allergies that were reported, but not all. I mean, that's the other conclusion we can draw. It's quite clear that in a number of cases, significant number of cases, no DMF was ever present around that product. Although it was probably a safe thing to do, banning DMF by the EU was definitely a knee-jerk reaction. And we've still got this problem that we're battling to overcome, that there's no official method at the moment of analysis. The storage and transport of the product, if it contains a sachet DMF, is critical. The way that it's heated up, cooled down, and then aired off at the end, it plays a vital part in whether you're going to get large build-ups of DMF or not. We still need, though, to protect leather against mould growth. And I've got some mould growing on a pair of leather trousers there on the slide. I could have used other leather items. That was just the easiest way to show the mould growth. So we still need to protect the leather while it's being transported from the Far East. It's packed, wet and warm, and that's the problem. So you do need some mould growth inhibitor. The mould growth inhibitor has got to be safe for the environment and safe for the person that's going to have the product at the end. It has been suggested that the patches that give off chlorine are a good way of doing this. They certainly work. They certainly work for footwear. It's also been suggested that silica gel is a good way of doing it. My conclusion on silica gel is to take out all the moisture in a pair of shoes, you would have to fill the box, the shoe box, with silica gel. Well, you just look at it, there's 2 grams in that little sachet. How much moisture is it going to pick up? Not a lot. And seriously, to get rid of the moisture in a pair of shoes, you'd have to fill the box. What would you have to put in a 3-piece suite? So silica gel is not the answer, but we still need something to protect during transit. And formaldehyde, certainly in some of the leathers we've looked at where we do know the history, does appear to offer another alternative to DMF as the cause of the dermatitic allergic reactions that we've been seeing. But, there's always a but, there could very well be other harmful substances waiting in there that yet undetected. And this is why this is an ongoing story, why the project is unfinished. We're still trying to find out what else might be in there that could explain some of these reactions. The formaldehyde does, the DMF does, but not for everything. Right, that's my final slide, which means it's time for me to be quiet. Thank you for your patience. If there are any questions, I'll be glad to answer them. Thank you.